what I want to do is kind of go to the next step. What we tried to establish before we went out to lunch was the Makey Makey is nothing more than just an extension of your keyboard. That's really all it is. If I can press a key on my keyboard to do something, play a piano, make Michael Jackson scream, whatever it was, if I can press a button on the keyboard, I can program the Makey Makey to do the same thing. So that's nice, and I'll tell you guys, that's what gets kids interested in it, that hook, that little piece, when they can see that they can play Tetris using a piece of paper and some like homemade keyboard buttons or whatever. That's all it takes for them to kind of say, this is cool, I want to learn more about it. But I'll tell you though, if that's where it ends, if that's where our instruction ends, then it's going to have a very small shelf life. You won't get much out of it for them. So what we have to do is go beyond the novelty of what that really is. And the way that we do that is we kind of look at the behind the scenes. So yes, it is an extension of the keyboard, but what if instead of me just saying press this key to make it play Michael Jackson, what if I actually taught my students how Michael Jackson's was being programmed, or how I was able to program the Tetris to work? So the way that we do that is we look at the behind the scenes, which is the programming side of it. So I asked that you guys all created a Scratch login. If you have that already going, boot up on your computer, boot it up, log into scratch.mit.edu. And I'll give you a little bit of history while you guys are doing that. Scratch itself was created years ago. There were people in the early 80s that had this idea of let's bring computer programming and mathematics to students. And they started at MIT, and then from there it's kind of like it's nurtured this philosophy of teaching kids how to program at a young age. And over the years and decades, that's what they've been really pushing for. So it almost makes sense that MIT would be like the birthplace of computer programming for kids at that age. So there was this idea of logo. Anyone that's was around in the 80s and 90s, logo or turtle art. Have you heard of those two words? Anyone that programmed at all in the past, you may have heard those at least. And there were people they were spending lots of money sending teachers to learn how to do logo or turtle art. And so that was kind of where we started. But computers were way too expensive then. They were kind of kept in a glass case in a classroom where no one was allowed to touch. But now they're everywhere. They're just on everyone's desks, right? So let's teach these kids how to use this. Scratch was the MIT brainchild. They were the ones that did this. And so that's kind of where we use it. And it's a great way of teaching programming because it's a very low entry, but there's a lot of possibility with it. So if you're in MIT, the scratch.mit.edu, that's in one window, and we'll kind of hop between two tabs. So you'll have to open up the Google Classroom, so classroom.google.com, and then the scratch.mit, two tabs opened up. And you'll see that I can, if you look on the top, and same on that window over there, you can see that I have my SKMP Classroom. And then if you look on the next tab over, I have a couple of other things open. So the best way I can do this, I can stand in front of you and teach you step by step, but it really is going to be difficult for me to kind of keep up. Everyone learns at a different pace. So what we did as part of our summer program is we developed these little programming modules. And that's what they are. And the kids have all went through these programming modules, and they've learned all these different types of how to program, really is what we're doing. So what I want to do is kind of show you guys a very small entry program that they started when they first were introduced to the Makey Makey. It was whack-a-mole. Are you guys familiar with whack-a-mole, the game, the arcade game, where you get a little handle and something pops up, you hit it, and you just kind of go repetitively over that? Very simple game in that way, but it's an interesting use of Play-Doh and the Makey Makey and the behind-the-scenes programming. So there are some subtleties, because if you've done code.org, then you're probably familiar with like initiation and like events that trigger. But we'll assume you know nothing, and we'll just kind of introduce it the same way that we do with our students. So what I would expect for you guys to do now, if you're on the SKMP website, the Google Classroom, go ahead and find the Makey Makey folder. And depending on your interface, if you're using an iPad, they will kind of condense it because the screen is smaller. So you may have to click on the folder and then search through the files and find this. But it's just called Whack-A-Mole, Conductive, Play-Doh, whatever. And I would encourage you, if you haven't already kind of learned a little bit about Scratch, there is a lot of tutorials on Scratch that you can actually go and look into if you just go into like the main homepage of Scratch. And there's a lot of help files, tutorials. One of the beautiful things about Scratch is that it actually allows you to see anyone else's computer program and their code. So if I wanted to find out how this guy made this cat with the flying taco, then I just click on it, and then it just shows like there's like a C inside. Well, I guess I have to click on one that's actually loaded, but C inside. And once you click on the C inside, it shows you all the code that's along with this. Now, this definitely is much more advanced. When I see all of this color and stuff, that's intimidating to a student. It's intimidating to me. I would have to spend some time learning what they're doing, but I'm certain that this is probably a really cool program that does some neat things. We're going to start with baby steps, and we'll let you guys go to however high of a ceiling you want to take it with your students. Depending on grade level, you may have different need. So I'm on Whack-A-Mole. I see that a lot of you are there already on Whack-A-Mole. So this was the challenge, and we approach a lot of this in the terms of engineering design challenges, and we ask our kids to create something. That's like the higher levels of Bloom's. We want them to create. So when I say create a Whack-A-Mole style game that utilizes the Makey Makey and Scratch programming, that's kind of where we started. But then we kind of go through some of the steps as scaffolding pieces. So looking at this, I'll just kind of show you the steps, and then you can kind of go back and forth from scratch, and I'll let you try this. But what we need to do is create a backdrop. And you'll see that it shows there's the tab that says make a backdrop, and then you can do like the fill color ins on the paint. And so you're going to make these circles. And as you go through this, you'll see step by step. Let's actually attempt this with Scratch ourselves. So if I am on scratch.mit.edu, I'm just going to load it up the same way you had it. And I need to make sure I'm logged in. If you're not logged in, do that, because you cannot save these to file unless your name is up in that top corner. So you'll want to save them. All right, so I want to create something from scratch, pardon the pun. From the beginning, we're going to create something with just a blank screen. So here is the environment, and I'll kind of talk to you guys about the color coding. There's a lot of different color cubes, but all of these have a different function. So like the motion, if you look at some of these instructions on motion, they will cause the cat to move in different directions. And I think you can actually click on them, and they'll show you what the cat does in those. So if I say point in direction 90 degrees, so it's just pointing, whatever it does there. So these will all be used if I want to make my cat move around on the screen or navigate. Typically, you'll always start with event, because this is the trigger that says when you click the space bar, start running this program. So I call them a hat, and I know that Scratch, the tutorials, also refer to it as a hat. If you think about it, it kind of looks like a hat. But the reason why is because programming is linear, left to right, top to bottom, with Scratch, this environment. So if you think about where a hat goes on the top of your head, this is where the top of the program is. So if you have a hat, that's the top of the program. So you'll notice that also these have puzzle piece kind of like notches in them. So I cannot connect a hat on top of another hat. They don't connect. But if I went to control, you can see that there is a that will link, and it actually highlights and shows, hey, this will connect. If you bring it close enough, it'll connect. And that means it is a sequenced piece of code. All right? If you want to ever delete anything, hold it with your mouse, and then just drag it over back to the steps. It removes it. So that's kind of the basics on how to add, subtract, like add code, remove code. Let's look at the background before we start anything else. So if I'm on Whack-A-Mole, the original PowerPoint, it says begin by making the backdrop. The wording was chosen carefully because that's what it's called on the program. So I'll keep this up on the screen for a second, but find out where it is on your Scratch program. It's called backdrop. And if you look on the screen of where I'm at, right here, right next to the cat, it's called stage backdrop. I'm going to click on that. Yeah, stage backdrop. So it's called the backdrop. And this is where I'm going to be creating the backdrop. So I can create the background for this cat. Now, the Whack-A-Mole screen itself says, go ahead and make 3 circles, like kind of elliptical circles. These are the holes that the cat is going to pop out of. So I'm going to walk around. I'm going to give you some time to kind of go through the first initial steps.
It takes a minute. Okay. You want your backdrop.
I don't know if the paint.
He wants like 3 holes, so you make 3 holes with that.
Okay, so what people are noticing is the backdrop is where you should be at. To make this paint happen, you have to be in the backdrop. Let me go to the Scratch program and show you how that looks. So I'm going into Scratch for my groups that are just seeing this. If I click on the stage backdrop right here, you don't want to click onto the cat. We want to add a background, and that happens in the stage backdrop. So once you're there, you have 3 options: to make a script, which is the code, the backdrop, or to import sounds. I'm in the paint editor. that's where I'm going to be able to make the circles. So you just select the tool that makes the circles, and then you right-click, drag, right-click, drag, right-click, drag. So now if you have these 3 holes already created, what I would recommend now is going to your paint fill, which is that bucket below the text button, and just select a background. So if I clicked outside of the circles with the paint bucket, everything will get filled in a certain color. So I just chose like a color of green because the ground is grass or whatever. So paint bucket, click, and then select the green or whatever color you want to do your whole background. When you click it, everything will fill in except for the centers of the circle. So it'll fill the background.
Maybe it makes a difference when looking. Never mind. Got it.
Now, do you see the colors of those blocks?
Here?
Yes. So do you see the colors of all those blocks? Those will help indicate which section they're in. So now go back into Scratch.
that's a yellow
See how that's like
one.
an orange color? So look for that one. If I'm in the scripts, that's where all these programming code blocks are. I want to go to Backdrop, which is a paint editor. Now, you're familiar with these icons are kind of universal. So I want to, if I wanted to add text, but I want to add a paint fill. So clicking on the paint fill, and then I chose like this darker color green. And if you click on it, boom, there it is. Now, maybe you want the holes, the centers of these circles, which is the hole, to be white. If you want to leave them white, that's perfectly fine. But I chose to contrast it with a lighter color green. So lighter color green changes the contrast. Now, here's the idea or the challenge that I had for my students. I want this Scratch Cat to kind of pop up out of this hole. So imagine he's disappeared below the hole, and then when it's triggered, he pops up. Right? Or he randomly goes to this one and pops up. Or he pops up here. So you do need to have, I was talking with a gentleman a minute ago, and you do need to have 3 circles because we're going to assign a value. Hole number 1, number 2, number 3. This is the behind the scenes piece that we'll have to include. So make sure that you have 3 circles. They don't have to be perfectly drawn or symmetrical in size, as long as we have the basic idea that this cat should jump out of this hole, or this one, hole number 1, 2, or 3. It'll make more sense when you see the code. Now, because I'm trying to walk around and help other people, if I get too slow for you and you're like, okay, we've been waiting here for a minute, there's no reason why you can't go to the actual PowerPoint and start working ahead. And what I would encourage. Let me also mention that this was an important point of learning for somebody, is that these programming blocks are actually kind of difficult to identify, especially if you're saying, where's the forever loop? You're clicking through each one of these sections. But I'm hoping you notice that they're color-coded. Do you notice that this when green flag is clicked is a special darker color of brown-orange? There's only one block or category of blocks that's that color. So that's why I'm teaching you about the color coding. It's much easier to then say, okay, it's events because the color is the same. So click on that. Or what if I want you to find a motion block? Well, the motion is blue. The looks are purple. So use the coloring to help you kind of distill all of the choices that you have. Does that make sense for you? So here's where we're starting at. It says the program's code starts with the Scratch Cat using a when the green flag is clicked. This is how you initiate a program. You start the program by clicking on the green flag. So that is the hat block, which is found in the events category. So if you click on events on your own program, click on events, grab the flag, when the flag is clicked, over to your area, and then go into control and find what's called a forever loop. Does everyone know what a forever loop is? 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 I'm giving you an example of a forever loop, sorry. So a forever loop is just repeat these instructions over and over again, whatever it is. If it's a comment, if it's a movement, it's going to happen forever. And that can get dangerous when programming because you can sometimes create programs that will never stop. They'll just keep going, especially if it's doing something bad, like a virus. Okay. So I don't know if I mentioned this, but this is a point of instruction that you'll need to make sure you clue on. And I put a big red arrow on the screen to show that in order to add this instruction, you should be clicked on the Scratch Cat. So please verify with your neighbor because someone in here is trying to put the code in onto the stage backdrop, and we don't want that to happen. So will you all just take a second, peer at your neighbor's screen, and make sure that they have the Scratch Cat selected at the bottom, and that they have the code on the scratch cat section. If it's not, then you're not going to be able to make the scratch cat move the way we want. Okay? Okay, I'll try to just introduce the next piece and then I'm going to walk around. We want this scratch cat to randomly pop up in any of those 3 holes. I'll repeat that. I want this scratch cat to randomly pop up. So in order for him to randomly pop up, we need to make a random number generator. Computers are great at doing this. So in order to make a random number generator, we have to actually go to the script that's called data, and we're going to create a variable. So I'm going to kind of walk around and help with this piece, but if you're on Scratch, if you need to look over here on the screen, there is this data icon, and it says make a variable. What am I going to name this? Did you guys see it on the PowerPoint? What am I? Random number. Exactly. So I'm going to name it random and capital N-U-M-B-E-R. No spaces. It will allow you to do spacing, but the conventions of computer programming, code in general, doesn't allow for spacing. They don't want space to be introduced. So I just kind of integrate that into all of my coding when I talk with students. Just no spaces. The computers and certain programming languages don't like spaces. So we won't use them in here as well. We'll do practices that'll carry over to other languages. So for all sprites, yes, this is default. We'll keep it default on most of the work we do. Hit OK. And now it gives you a couple of options for data. All right. I'm going to walk around and see that people have a random number variable created. That's what I'm going to do. You're more than welcome to move ahead to the next slides. We're going to test block number 1 only first. So that's the first step. So go ahead and go to the next slide and then continue with your steps. You're having concerns about, so if you want to click on the third one, yeah. Whack-a-mole.
Why am I not?
Okay, so do you see how it lit up? Watch. Yeah. It lights, there's a real faint highlight that says this is actively running.
Okay.
So now you put 5 in there, and let's go ahead and test.
Yeah, it's 15.
Okay, either way. Now that many of you guys have moved ahead, it's worth talking together as a group. So let me have everyone looking at the front screen so we can make sure that we understand what it is that I'm talking about. It asked me to go through the code and create the background. Done. Then it said create an initiation flag, which says when the green flag is clicked, then start the forever loop. The green flag is this right here at the top right corner. It says if you click that green flag, you initiate the program. That's why when I click the green flag, my forever loop starts. That's what you should have had already started to build. So when I click this, notice that it lights up. Can you see this on my screen? Yes. Let me stop it and start it again so you can actually see the change in colors. Start, stop, start, stop. So you should be able to know when your program is running. If you see it highlighted or highlit, then you'll know that it's running. So I can also do a double click from here. This is a subtle thing that you probably didn't notice. If you double click on the actual block, it will engage the program, shortcut. And double clicking again will turn it off, or single click will turn it off. So single click turn on, single click turn off. You can do it that way. Now, the parts that people were concerned about was the next steps where you had to create your random number, and you've done that. So then let me go into present mode here. It said to get the scratch cat to randomly pop up in any of the 3 holes, we need to create a random number generator, 1 through 3. So a lot of you went in and typed in the number 1 and then typed in the number 3, which is what you should have done. But when we get to a point where we want to test, then we're going to change those values just so I can test, see if it's popping up in the hole the right way. So I asked the class, and this is what my students were having conversations with the kids about, because I want them to think about the code, not just copy the code. Part of the conversation I was having with someone is programming should be more about the process and not the product. The final product is great. We get a cat to pop up out of the hole. But we could have done that with paper and pencil. The product or the process is really what I'm trying to teach here. So I ask them intermediately throughout the programming, I like to ask them questions that cause them to think about the code. What would happen if we change these numbers from 1 to 3? What if I put in 5 to 10? Out loud, what would I get as a result if I change these random values from 1 to 3 to 5 to 10? What kind of values should I get? Give me an example of a value output. The value output of the random. So if I have set random numbers, pick 1 to 3, but if I changed it from 5 to 10, give me an output value. 7, what else would work? 9, what else? 6, 10. So those are the numbers that I would expect to see showing up on the screen. And let me kind of go back. As soon as you put in your random variable, when you put that in onto your program, did you notice this popped up right here on the top corner? It pops up and it says, this is the value that you have stored in random variable. So adding all of this extra pieces to it, set random number to, I don't even remember what the code was showing, but set the random number. Whenever I'm picking a random number, then it will tell me what the random numbers are right here. Now, at some point, you guys, or all of you in the groups, were picking the numbers, and you're like, well, why did you want it to be 1 to 1? You said put 1 to 3 right here. Why do you want me to change it to 1 to 1? Because what I want to do is test whole number 1. If I can get that cat to randomly pop up when the number says 1, he pops up on the hole right here, and he waits for me to hit a button on the keyboard before he disappears. I want to make sure it works on hole number 1 first. I don't want to draw a whole page of code and find out there's a mistake in all of them. So I want to debug whatever's going wrong here on hole number 1 first, and then after that it's just copy paste to make it hole number 2, copy paste, make it hole number 3. Very simple in that sense. There is one other thing that I want to show you about this. If you click and hold on to the mouse and move them, or the cat, and you move them around, take a look in the bottom corner. Let me show you what I'm talking about. Take a look in the bottom corner of your screen right here. As you grab this cat and you move him around, what are you noticing change about your X and your Y? Those are your coordinates. This is math we're talking about here. Starting with, this is a 4-quadrant plane, and if I move my cat in the left, he's going negative X. If I move him right, he's going positive X. If I move him up, positive Y, negative Y. So we now have connection to math standards here. If I'm trying to get this cat to move around, coordinates, just teaching kids where, or meaning to that. It's not just a worksheet anymore, it's actual meaning to those numbers. I want that cat to pop up right there at that exact spot. So on my X and Y, I have to mouse over to that, or move your mouse arrow over and say, oh look, it's at mine is negative 143, 38. So when I plug in my values, that's what you're going to have to do. Now your coordinates may not be the same as mine, so don't just copy what I have on this screen. That is intentional, by the way. I want you guys to go in and figure out what your X and Y numbers are for the cat at hole number 1. So questions on this as a whole group. Can we address any kind of concerns that you may have on this piece? If you can get your cat, and this is what I was telling people to do, move your cat to some arbitrary location on the graph or on this plane, run your program. If the cat automatically bounces back to hole number 1 and waits for you to hit a button, then you're ready to go on to step 2, to duplicate that code and make him do the same for hole number 2 and then hole number 3. I would love to see someone show me, or show the group around you, that you have the cat that's hopping from hole number 1 randomly to 3, randomly to 2, whichever one, it's there, that's where you're at. So I'm going to kind of walk around. Go ahead and use this as your piece to help you kind of go steps ahead, but that's what you should be looking at. But here's the situation that I have now. All he's doing is you're just kind of animating him, right. But are we actually going to ask for user input? If he's on hole number 1, right. What should I do to make my user, like with the Makey Makey?
Like a space bar.
Yeah, so I'm going to wait for some kind of sensing, right, from the, and so that's where if you go back to the program, it'll show you, you're going to have to add some key elements to your loops.
Okay.
So you're feeling good about that, and you're able to get them moving on?
Yeah.
So you're now looking back on the code and then look for the next steps. Do you see how there's a, so yeah, just go from there. Let's look at the last pieces of hole number 1. If you're able to get hole number 1 to work, then hole number 2 and 3 is nothing more than just copy and pasting it and then adapting the numbers to line up with it. But I'm going to look at hole number 1. Let me zoom in or go into present mode. Take a look at this, please, with me. I want to kind of go line by line and discuss the details of hole number 1. So that way we have a decent understanding of what exactly this code is asking us to do. Of course, when I click the green flag, it initiates the program. This is your initiation block. Forever loop says anything that's held within these boundaries will repeat forever. No ands, ifs, or buts. It's just going to go on forever. Now, I put the wait 1 second in there because a forever loop and programming typically runs in microseconds or milliseconds, so we don't have, it's not going to be fast. So we have to build in pauses. So that's why I have the wait at the very top. So after it finishes this, it gives it just a 1 second pause to allow you to reset. Now you can change these values to 0.5 of a second, a fifth of a second, a tenth of a second. Depends on what you want from your program. And if you want to make it more challenging, make it shorter, and the kids have to move faster, right? So then it shows hide right here. And the reason why is because it pops up in different parts of the program, and you just want to make sure that you have this built in. After you have all these blocks, that hide will be important for you. We've talked about how to make a random number. There's this situation right here, this if. These are conditional statements, and these are kind of what programming is really based on. This is kind of like a false way of getting the computer to think. It almost makes it feel like it's coming alive when you ask conditional statements or when you build conditional statements. If the random number is 1, send it to the whole number 1, whatever your numbers are, and then make the cat show up. We want the cat to look like he's popping out of the hole, so that's why it says show. Now, here's the part where it's going to stop and wait until you've assigned it some sensing. We want to be able to use our Makey Makey with this. If you do not say wait until the keyboard is pressed, then it will not, it'll just keep popping up and it'll just hop around from hole 1, 2, and 3. It just keeps repeating over and over again. So we want to integrate some sensing from the outside world, or keyboard press, or in our case, our Makey Makey. Take note of whatever you used. If you said keyboard spread or key space, then you need to make sure you hook up your Makey Makey to the space on the, like the icon that shows space. If you hook it up to like the letter J, there is no letter J on the Makey Makey. So you will never be able to make the Makey Makey work. It's got to be assigned to the space bar. Now, I've added this change the score. Don't worry about doing the score, random number score, unless you've already got this program running and everything else. But just focus on making that cat pop up, so then you can bring your Makey Makey in and continue. I also added a note, so that way it kind of makes some sound. It senses that you hit the keypad. Sometimes with conductivity, the Play-Doh doesn't work as well. You hit it, it didn't actually move. So if you don't hear a sound, then you hit it again. That's kind of why we added the sound. Once you have this running, then all you do is, if you're using a Chromebook, it's 2-finger press on the trackpad. That's right-click. And you can just copy-paste it. So you should have 3 loops that are going on in here. So it's if this, then if hole 2, then if hole number 3. Okay? So I'm going to kind of walk by and see where you're at, but this is the way it should look as a final product. If 1, if 2, and then if 3 at the bottom. I'm going to say if you're already got a product working and you want to keep score of that stuff, great, do that. But it's more of an advanced idea that we don't need today. We're kind of trying to learn how to integrate the Makey Makey into coding. So getting those 3 if statements set up, changing your coordinates so the cat actually pops up above the hole, that type of thing is what I would hope to see. And I'd like to see people starting to get their Play-Doh out, making small little balls, connecting the Play-Doh to those, and then just seeing if you can make the whack-a-mole actually come to life. Let's see if that happens. And I want to delete this. So what I'm going to do is if I go to the hat, when you double tap, that's right click. So with your trackpad, 2 fingers on the trackpad, same time, and it's all the way up. So we should hear, click on that purple note really quickly. Just double click that purple note. Yep. I'm going to just take a second, give you just 2 directions to go, because there are some of you here that are like, you've just finished your coding and you want to make this work with your Makey Makey. I encourage that. Again, it's process over product. So I encourage you to continue building on this and to make it work. But there are a few of you guys that have made it work. You've changed, you've added voices, you've done about as much as you can with this program. Now you're ready for something different, or you at least want to explore some other things on there. I'm going to recommend that you at least just kind of look at some of the other programs that we have built onto this, onto the class page. So let me walk over there and just walk you through something, and then I'm going to let you guys finish off with whatever you decide to do. I had lofty goals. When I was planning for today's PD. I was hoping that we'd be able to do all of these things, but you do really have to kind of go off of what the class is ready for, and that's fine. I'm okay with that. So the whack-a-mole game is a great way to introduce how to play Makey Makey with the computer, because you have to learn Scratch, you have to learn a little bit about programming before you can make it work. But once it works, it's great, it worked. The next one that I do with my students, and we've played this in summer camp, and it's called it's an obstacle course, and you actually have to stand up and do like a balance beam kind of setup to make this work. It does the same thing. At this point in the day, you guys are all pretty conductive on your feet. And the reason why, what it does is it uses foil, and you can create these little rails And think about this. You're holding the ground in one hand. So you have a wire, and this is an example where you use magnetic wire, that spool of wire, so that way you have a little bit more length to walk with. But look, they set up a track that's maybe 3 feet long, and then it makes a 90-degree turn, and they put different obstacles. Some of the kids like to put a box on the floor, so they have to step over it. But what you're doing is you're creating a conductive circuit with your body, the ground, and then you're touching the foil, which is going to have a Makey Makey plugged into it. One key only necessary. And the programming is this interesting is because it's saying as long as you're touching that foil and you have a ground in your hand, you're going to complete a circuit and nothing happens. At some point you fall off of the track or you step off of it and then it breaks the circuit. That's when the computer says you've broken the circuit, game over, and it tells you what you did wrong. So the kids made these and they do timers on them. And they do all kinds of extensions for this. But what I would like to see, anyone that's interested in doing this, the code is really simple. It's much less advanced. But what you do is you take some foil, you tape it to the ground, and then you just build the code. And it's built into this. And the kids love this being interactive. They love being able to make stuff on the ground and then go from there. So you have to actually have your shoes off to make that work. I read your mind. I read your mind. Years in school. So yes, the shoe itself is going to have the rubber part of your sole if you're wearing shoes at all. So that is not conductive. So you actually have to take your shoes off. And I said at this point of the day is because probably at this point of the day you've been wearing shoes long enough. Your feet are probably moist enough to where it's going to be a good conductive signal. So, right? So we won't reuse this foil for food purposes, but it's definitely something you can use. Yeah. So take a look at this. If you are interested in making one of these obstacle courses, we have about, 30, 40 minutes of class time where we can do this type of thing. If you want to continue working on the whack-a-mole, those are 2 directions I'm going to give. So go ahead and start and do one way or the other. How far did we go?
So I figure we do it in 3, that way it's narrower, to make it harder.
Now, my concern would be the fact that it's going to have to be a circuit, a circle. Right. So if I'm going to have a connector connected right here, that break causes an open circuit. Now you can do the same concept, but put an obstacle in the way, a small box or something, so they can't actually, so the same thing is still being achieved, except that there's pass of a circle here, so that we have our circuit. Okay. If you have the foil connected on this end, so it would, exactly, the break in the system. Exactly.
You guys ready? I'm off to see the wizard, the wonderful
A lot of people are asking about some of the files, and you are all welcome to use any of the stuff that I've presented and these things. Now, because it's under Google Class, the way that you can access this is you go into your Google Classroom from the CSUB LE website, those domain names, and then you just share it to your personal email. So if you right-click on, or like you go into the drive, you can just right-click or whatever, and then share it to your personal email. And then if you're in Google Chrome, you're on your personal side, then you can just look under the shared with me and just download to your computer, so you have access to all those things. So I would recommend you do that in the next couple of days, because we reuse these login names with different PDs, and we'll just delete whatever's on there.